In this exercise, we are given a first-order language consisting of 3 sets, as you already know. The set of variables, so we can use 3 variables, x, y, and z. Then the predicates are given. We have a predicate p with 3 required parameters and q with 1 required parameter. And finally, we can use those functions. C is a constant since it does not have any parameter. F requires 1, G requires 2 parameters. And the task now is to check all those 4 formulas if they are syntactically correct, or more precisely, we have 4 character strings given, and we have to check if they respect the definition of a formula. They respect all the rules in that definition, and if they do, then we can say that they are formulas. Otherwise, they are not. So let's start with the first one, and let's start at the beginning. Well, at the beginning, we are using a negation, which is correctly used because it is followed by a formula. This is a formula indeed, since it has a true-false value, because we are using a predicate at the beginning. So the question is now if we are using the predicate in a correct way. The only source of mistakes is the wrong parameterization. Are we using a correct number of predicates? Here we are using 1, 2, 3 parameters, which is correct because P requires 3 parameters. So this is so far correct. Then in a similar way, it is also a source of mistakes is to use a wrong number of parameters for functions. For instance, here I'm calling the function f with 1 parameter, which is completely correct. And then I'm using c here, 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 and here without any parameters, and this is correct since c is defined as a constant. And I'm also using g, the function g. So I'm calling g with 2 parameters here. This is, you see, it's correct. And I'm also calling g here with 2 parameters, which is also correct. So we can say that, yes, the first string is a formula. Let's check out the second one. In the second one, well, we can start with the main logical operator equivalence, which is supposed to have 2 sides. And it has 2 sides. So far, this is all right. Then we have to check the 2 operands one by one. So first of all, in the first operand, we are using a universal quantifier with a variable. This is really important. The quantifier must be followed by a variable, and this holds in this case. Great. And the variable must be followed by a formula. Is this a formula? It looks like that. It looks like one, since we negate a predicate, and the predicate is parameterized in a correct way. Q has only 1 parameter, and G as a function has 2 parameters. So the left-hand side is correct. What about the right-hand side? Well, the right-hand side starts with a negation. A negation must be followed by a formula. Is this a formula? Well, it looks like one. So check if it is a formula. It starts with a quantifier followed by a variable, really good, followed by a parameterized predicate, and the number of parameters is 3. So this is also correct. This means that the second string is also a formula. The third one starts with a universal quantifier followed by a variable. So far, so good. Then between parentheses, we can find an implication which has 2 sides. This is very nice. The left-hand side is a negated predicate with 1 parameter. Good. The right-hand side starts with a existential quantifier followed by a variable followed by a possible formula. So let's see if this is a formula. It starts with a predicate, which is really nice. We only have to pass a parameter to this predicate, one parameter in this case. But this parameter must be a term. A term can be either a variable, a constant, or a function call. As you can see, this is none of them. This is a parameterized predicate. Actually, this is not a term. This is an atom. So this is not correct. And maybe you can remember this. It is always incorrect to pass a predicate as a parameter to another predicate. This never works. Okay, so the third string is not a formula. Let's check out the last one. Long story short, I can immediately spot an error. Here, I'm using an existential quantifier followed by a constant. This is prohibited. A quantifier must always be followed by a variable, and C is a constant, so this is not correct either.